caught up perfectly. Okay, so yeah, thanks for everybody that's joining me tonight. Those are going to catch this later on if I get a chance to actually upload it. But yeah, so I've been kind of streaming about building VR development, basically in general, for a little while now. So if so, those of you that are following the Twitch channel. Good news is I'm also now over on Channel 9, so that's really cool. Welcome to all the Channel 9 viewers. Very, very awesome to have you guys with me. So just to kind of catch everybody up, just to do a recap, where I'm at is I want to build a game engine. Specifically, I'm trying to make sure that it's kind of tailored towards working with mixed reality, VR, and potentially AR down the road. So, I tested out a couple of different options. I went through. I've built engines before in the past. Like, I've worked extensively with DirectX since 9 through 10 and 11. As well as I've done some OpenGL work. I built an OpenGL engine. So I was kind of like, kind of hemming and hawing about what technology I kind of wanted to lean towards. But in the end, because a lot of the development is being done on the Windows platform, it just kind of made sense that I would lean toward its strengths, and with the release of DirectX 12 and the amount of performance that you can get out of it. And if you guys have been following any of my tweets and that, I've been playing around with it. I've absolutely fallen in love with DirectX 12, and it's a little bit more low level than DirectX 11 in the regards of, hand holding and having a developer kind of um, having to take the role of working, and saving resources and managing resources, and there's a couple of different concepts like working with command lists and queues. Um, it's a little bit different, and it's kind of been a learning curve for myself. So as I'm kind of going through this, I've decided, hey, I'm going to build this engine and turn it into a demo series at the same time. So yeah, hopefully that was a quick recap of everything. So where I'm at right now is I've got this running right now. So here's my demo engine. Um, and basically all it is just bringing up a window and then showing some frame rates and whatnot. So nothing too crazy there, but it's a start, and this is kind of where I'm going from. I don't think that the video from the last time I was building this out actually got uploaded, so I'm gonna re-upload that. So if you're kind of like, oh, how did he get to this point? Don't worry, I'll make sure the video gets up on Channel 9 as well, so you guys can see that. So yeah, that's kind of where I'm at. But what I've done a little bit differently, and I should note a lot of this is code that I'm bringing in from like my older engines, so stuff that I've done with DirectX 11, and a lot of that I've learned from not only my own schooling and when I was doing DirectX 9 and 10, but also through reading some really really good books by Frank D. Luna, who builds these amazing or writes these amazing books that that kind of walk you through everything. It's been a series. I think he's been doing it since like DirectX, God, I don't know, 8 or 9. But yeah, that's kind of where I picked up my knowledge. So if you want to really really deep dive, and I believe yeah I got the DirectX 12 one now, so it's out, and you can kind of go through that one to see some of the cool stuff. So what I've done is I've taken a couple of different tutorials and I've built them out. So what I'm doing is instead of coding everything inside of like one project, or in this case I've separated them into just separate solutions, and just for me for tracking, eventually I'm going to move them both into the same solution. But instead of building it all out in one project and having this like demo engine that also had a bunch of demos on how to do things, what I really want to do is separate the engine and the actual like gameplay mechanics code. So I thought, instead of building it out and then doing that later on down the road, I'm doing it right off the bat. So what I've done here is I've created this demo engine, and again, check out the video from before, and this is all being saved out as a static library for now. And then I can just basically take that library into my other project, which is my example project. And I got a few other projects open. One of them is my OpenGL one because I'm kind of referencing it on how I did some of the stuff there. But yeah, so basically all I'm doing is, and then all I have to do in my example project is include my demo engine and my library. And then it's, I basically expose just some simple stuff like, the initialization, on resize, resizing windows, and then update and draw. So very, very simplistic as it stands now, but a lot more to come in the future. So what I wanted to do today, and I might note that I'm literally doing this all raw, so you will see live mistakes and things like that. So people on channel 9 that haven't seen this before, yeah, this is live coding and I do make a pile of mistakes. But what I wanted to do is kind of walk through building some helper classes. So as I move forward, obviously I'm going to need a lot of extra little helper classes, and right now we got engine utils that are in here. We have the DDS loader, which actually comes from Microsoft, which allows me to load in some DDS files. Had this around since DirectX 11. We have a game timer, and things like that, but we're going to need some more. So some of the files that I'm going to need, and these are the ones that I was thinking about working on today specifically, so we'll just add the headers for now. So the first one, it'll probably, the one that scares everyone, the math helper. So in our math helper, luckily, one of the really cool things about DirectX is in 12 especially, is there's a library called DirectX Math, and I'll dig into that a little bit in a second. It does a lot of the stuff for us that, thank God, we don't have to code, because there's a lot of really, really fine nuanced details in writing a good math library. But there's also some stuff that it just kind of leaves out, or isn't abstracted enough, and requires a lot of, a lot of typing just to get something very simplistic back. So I'm going to write basically just a simple helper class that will kind of fill in those gaps. Outside of the math helper, another one that I'm going to need, and this is something that I highly suggest if you're building your own engine, that you have right off the bat. I'm just going to call mine logger. Basically, it's just a basic system to log all the details of the program when it's running, especially when you're debugging stuff. So one of the things that I'm going to want probably in my log is the hardware. I want to pull the hardware, see what the person's running, and then spit that out into a log. Any errors, right? Things like that. So this kind of be like a catch-all for basically, and we can build it so that it'll have separate logs, like error log, runtime log, things like that. Because as we get going, and the end goal here is to make a very performant VR engine, we're going to want to make sure that we're seeing what our outcomes are, and we can kind of judge from there whether or not our perceived performance increases are actually happening or not. So that's one. And then another one that I'm probably going to want to do, and I don't know how many I'll get done tonight, because I'm not going to stream too long tonight. But probably, I guess exceptions. I'll just call it exception for now. So I want to write some sort of simple system to do verbose exception handling. So basically, we want to start, throwing and catching exceptions and handling them gracefully, but at the same time, we want to build something that's very intuitive, so that as we're coding, we don't have to, build this monolithic structure. So we'll kind of put that in there. So those are the three helper classes, and obviously they'll get bigger as we go, but they're kind of the ones that I want to focus on right now. So let's see. I guess we can begin. Sorry, I'm just looking at my notes here. So let's begin with the math helper. Okay, so let's just do this. Going to include a few things. let's do DirectX first. So we'll do DirectX Math. So DirectX Math, again, it's going to have a lot of the really kind of important things, like the one that I was looking at before, just to kind of show you guys, was XM vector. Oh, it's not in the right. Oops. I believe it's in. Yes, this is also part. See, like, it's not totally included in the DirectX Math, but I think it's fact vector. No? Am I still wrong? Strange. Oh, silly me. Namespace, I believe, is my issue. Yeah. Let's see, do we have vector in here? Sorry, headset decided to kick out there. Always something. Alright, so yeah, the XM vector. So this has a lot of built-in things. So this is what we can store all of our vector classes as, and you'll see this as they start building out the engine and stuff like that. So there's a lot of things in there. So we don't need to build out our own vector class. I don't need to go that deep in building my my math library, which is very, very thankful, because there's a lot of very helpful functions inside of here. Let me see if I can find a couple, like so vector. So like, vector 2 dot. So like all your dot products, your cross, getting angles, finding angles between vectors. A lot of these are already done for us, so we don't need to actually write them, which is such a huge help. Trust me. So yeah, like I just brought up the MSDN website. So if you're looking for this, you just do a quick search on DirectX Math. And this will, if you go to the MSDN library, it's kind of a few clicks into to get really kind of deep. But if you go to the reference, it'll start to like list everything that it has available. So in our functions, there's a lot of very helpful functions. There's a lot for matrices, working with quaternions, which you'll see becomes very, very helpful in the future. But yes, I do digress. The good thing is it does have a lot of the stuff that we need, so we don't need to fill in too many blanks. But there are a couple that we're going to want. So let's call this class Math Helper. Alright, to start with, let's just do some like pseudo code here. So a couple of the ones that right off the bat that we're probably going to want is just a basic min and a max function. So what we'll do is we'll be able to pass in basically, and we'll build these out as templates. So if you haven't seen any templates, it'd be kind of cool to see that too as well. But what we'll do is we'll build these out so that we can pass in pretty much anything, and it'll check, provided that the operators are in place to do the check on the objects. It'll check between them to see which one's larger. So we can pass in floats and whatever we want. So having something simple like that, it's just that extra layer of abstraction, and these are really, really simple to code, so not too difficult there. Another one that I always like to have is a Lerp function. Now there are certain Lerp functions, and you're probably thinking to yourself, all these are already in, like, in math, the math library from the standard lib file. But the reason that I'm doing it this way is, one, it gives me a greater level of control, and two, I don't have to bring in the entire library of things that I'll probably never use. And, hey, it's kind of a good chance to learn something. So that's why I'm not just using the standard library implementations here. I'm building out my own because, one, I want a little bit of extra control over a couple of different things, and to down the road, we can kind of add to this and only use the things that we're going to actually want. All right, and then let's see, what else would we want? A clamp. So basically just a simple function to make sure that a variable stays within a certain range. Again, very handy. There is, again, ones in the library already, I believe, in DirectX Math already for like clamping a vector 3 and a vector 2 and blah, 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 blah. But at the end of the day, with one simple, pretty much one line of code, we can make that function. So it saves us a little bit there. What else? I should have wrote down a list of ones that I was going to want. Would have helped. Well, some constants that we could have, some just so that we can always have them. Again, this one is available in the math library, but pi would always be nice to have. And then another one that, again, we're just going to use this simply as an abstraction is an infinite variable. I'm trying to think of a better thing to call it. I guess infinity is good enough. So basically, all this function will do is return largest possible value. So that's all we're going to do with that one, is just return the largest possible value on the platform that we're currently on. End of the day, DirectX 12 runs on a lot of different platforms with Windows 10. So yeah, might be a good idea to know what the largest possible value is. And also it comes in handy when we're doing some neat tricks with like UI and stuff like that down the road. Random numbers and all that fun stuff. Okay. Yeah, I guess we could have some random numbers in here. The rand function works. So, I don't know. A bunch of different stuff we could do there. Let's see. One last one that we should have. And again, this is like really simple to create on the fly, but we wanted some abstraction. So let's make an identity matrix that we're going to. Oh, jeez, I can't spell tonight. An identity matrix. So basically, and specifically, a 4x4 matrix. So one of the things, like especially when you're moving around objects and stuff like that, is you always need an identity matrix. And hey, why not just create something that returns a very simple 4x4 matrix? And I think there might even be a already existing. Yeah, there probably is. But anyway, this is a nice little learning curve. Okay, so let's, or a learning exercise. So let's start, and for the most part, we can pretty much do all of these in a editor. Makes it a little bit more lightweight and easier to transport around. So let's start with minimum. So, like I said, what I want to do is create this as a template, and the reason for that is we can use it with a lot of different variables that way. So we're going to create a templated function, and it'll be static. So that way you don't need an instance of the math helper. Static t for our type name, and then min. And min will take a constant t. Of course, I will pass that through as a reference to make it nice and clean. And then another const type t. We'll call this one b. So minimum is going to take in a value a and a value b, and then all we're going to do is return. Return a simple. Well, we could say. We'll do it this way first, just so we can see the difference. So if a is greater than, or if a is less than b, we can return A, and then else return B. So, so this is like a really simple, obviously, because we just want to return the minimum one. So whatever one you pass in that is smaller, we return. But we could do this a little bit easier, or I shouldn't say easier, but a little bit cleaner, and do it all in one line using a conditional ternary operator. So just because I'm trying to do everything kind of neat and as modern C++ as possible, we'll use one here. So basically what we could say is something along the lines of like, so return if A is less than B, and this is where we put the ternary, conditional ternary operator, which is the question mark. And then what it'll do is it's a true, and then on the other side false. So if this case was true, we want to pass A. Else if it's not, we'll pass false. So that's basically how that reads. It says if A is greater than B, then it runs the check and it says, okay, yeah, you know, if say A was 0 and B was 1, this is true, so it'll return A. If it's not, it'll return the secondary result, which just happens to be B. So that's how a conditional ternary operator works if you haven't seen one of those before. So there's our minimum. Now we can create our maximum. We'll just do this the same way, pretty much. And again, it'll take in const t. We'll call it A again. Alright, and then same thing, we can just use our conditional here. So in this case it will be return. I'm sorry. All it is a flip of the sign, so we just check to see if A is greater than B, and then do our returns. So there we go. So there's our min and max. That's pretty simple. But we could pass in anything we want now, right? We could pass in a int, we could pass in a float, we could pass in a string, but it will only work provided the fact that this operator works on the variable being passed in. So that's how templates work. If the variable is being passed in, say it was like a custom variable that didn't have a greater than or less than operator overload, it'll just basically spit out an error. So yeah, this will work on anything that does have that operator overloaded or implemented. Okay. Alright, so now our Lerp. So Lerp, believe it or not, is actually very simple to do. And it's also a very handy function that you'll use in a lot of different circumstances. You can use it, you know, for moving animations, you know, sprites around the screen. You could do it for placement of other objects. I've done it for networking smoothing, like using it as like a smoothing algorithm. So, you know, basically all a Lerp does is it's linear I'm gonna get this wrong. Linear rotation over time. Oh Jesus, I'm forgetting how the acronym goes. But basically, all it does is it linearly interpolates between two objects. So basically, what it does is it says, okay, here's the distance between A and B. I'm going to give it a certain amount of time that I want it to take to get between those two objects, and then it slices it up nicely and evenly so that it moves at a constant rate over time. I guess I hope that I explained that properly. Kind of feel like I butchered that, but anyway, it's very simple to actually set up, and we're going to do this with a templated function because we want to make these. Oh, geez, I just realized I made a huge typo there. I should be type name. So template type name. Yeah, we want to create these templated functions just so that this library becomes more useful down the road. You can always pull this header out and use it in other functions or other projects. So, and again, we'll make this one static, and it will return a type T, and we will call it Lerp. So what Lerp will need to take in, obviously, is 2 points. So we will have a const type a, do that as a reference, and then of course we will have another one. Okay, and then what it also needs is time. So this is what it'll use to calculate and slice up the linear path, if you will, evenly. So just thought to myself, do I really want to force this to be a float? Okay, for now we'll leave this as a float. Most times, you know what, I'm going to make this a double. I'm trying to follow the newest conventions that have been coming out of the C++ community, and one of them is it's better to use double instead of a float, or at least that's what I've been hearing anyway. Does give you better precision. So okay, so what we're going to do here is we're going to basically take point A, and then we're going to add the distance between point B and point A to point A, and then we're going to times that by time. Okay, so I hope I'm explaining this right. So we're going to take so point, so starting point, okay, so starting point A plus the distance, the distance, like the difference with the distance between A and B, and then of course we will times that all by our time. Okay, so we can really do this really easy. Again, we can do this all in one line. So we'll say return A, so our starting point, plus, and the easiest way to get the distance between the point A and B is to say point B minus point A. So that'll actually tell us the distance between the two, and then we could just say times that by time. And that is literally probably the simplest Lerp function you can write. Let's get rid of that comment because we don't need that. It's pretty self-explanatory, but I wanted to go a little deeper there. Okay, now what else? All right, we can do our clamp. All right, how am I doing on time? I got a few more minutes. All right, so again, we'll make this a template. Type name T. And again, it will be a static function. It will. Oh, God, my fingers are just not keeping up to me today, or I'm not keeping up to my fingers. One of the two. All right, so it'll return a type T. And clamp. Clamp's going to take 3 different variables. 2, 3, 3. Yes, 3. Okay, so we're going to need, well, the object that you want to clamp, right? So we'll pass in that, and then the variables, so the lowest it can be and the highest it can be, and then it'll clamp it between those 2 objects. And this is really good for, if you're doing like random number generation on objects, and you want to clamp it between like two ranges. So like, like spell casting and stuff like that for an NPC or something like that. Having a very, very simple function, again, that's templated like this will come in really handy. And again, yes, there is clamp in math and Again, I think it is templated and you can pass in a bunch of different stuff. But down the road, this is completely templated. So if we did create our own custom variables, or object types or whatever it might be, we can start using those as long as, again, we have the operator implemented or overloaded. Okay, so clamp will take in 3, so we'll start with const t, always passing them in so that we don't make copies. What should we call this one? Kind of want it to be verbose, but because usually I would just like be like I, or XYZ, or IJK. Let's say I'm just gonna call it I, because it's gonna be pretty evident anyway. Thinking about this way too much. And then a high. Okay, so now we have a highest and a lowest. And again, this function, and believe it or not, it can be done again using a conditional ternary operator. We can actually do this very simply in one line. So what we'll say is basically it boils down to we want to check to see, so is I less than the lowest part? And if it's not, set it to, or if it, okay, so if I is less than our lowest value, which it shouldn't be because we want to keep it in these ranges, then we're going to set it to the lowest value possible, right? Because x can't be lower, or I can't be lower than this number. And then what we'll do is we'll do another check. So if x is greater than the lowest number, sorry, we will we'll do another check to see if x, I keep calling it XYZ, it's stuck in my head. We'll do another check to see if I is greater than the highest point that we're allowed to do. And if it's greater than that, then we'll clamp it back by setting it to the highest, right? Makes sense. And then if neither one of those are true, it doesn't matter, it's within range. Okay, so we should just type this kind of out really fast. We'll just do it really quickly because I'm blowing through a lot of time here. So return I if I is less than our lowest point. And we'll bring in our ternary operator. We will say, okay, so then it's set to low. So that takes care of our lowest value. So, the next thing we need to do is build our high side of things. So we're going to do another check actually inside of our result. So very kind of cool way of doing it, and keeps it all in one line. So keep losing my mind here. So I is greater than our highest. So we do another check, and then we turn ternary operator. So if it is, set it back to highest, so that'll return highest. And if it's not, just return I. Okay? So, yeah, I think that's right. Yeah, it makes sense. Okay, so yeah, I less than lowest. Okay, set it to low. If it's not, do another check, make sure it's not higher than the highest. If it is, set it to clamp it to the highest. If not, just return I. Simple enough, one-liner, very, very handy, and you'll see as we move forward, I will be using that one quite often, I'm sure. Alright, so let's take a look at our constants, and like, God, these are so easy to do. It's almost trivial, but, so I'm just checking to make sure the audio is still running here. Yeah, it seems to be okay. Alright, oh, did I open the wrong? Yeah, I did. Alright, there we go. Alright, so let's start with pi. So pi, usually, and see, this is where you got to kind of make a decision, because if I start writing everything with doubles, I'm gonna be stuck with doubles for the rest of this engine. Alright, well, I already wrote one, so whatever. We'll stick with it for now. Please don't come back to bite me later on. Alright, so we'll say, const double, and we'll call this one, pi. And then we can give pi, let's see. Wonder if this. Alright. So just trying to grab, just double checking here. Oh, this is interesting. Okay, but anyway, I just wanted the value that it largest value you can hold is a double, which appears to be that. So there's our pi, a very, very accurate pi. Let's see. What can we do next? I'm gonna skip the infinity one just because that one's simple and I'm running out of time. I don't want to take too much more time up here. What we'll do is we'll do a simple return for a identity matrix. Now the way I'm going to write it here is going to actually kind of tie it to DirectX specifically, but considering a lot of the other things that we're going to be doing, we'll be tying it to DirectX. That is fine, but in the future it might be it might be a good idea to oh, that's not what I want. It's XM float 4. Okay. No, because that was only a float. We need a float. Oh, sorry. Float 4x4. Is that right? Yes, okay. Alright, so what we want to do here is, basically what I want to do is make a very, very simple method that I can call that will just return an identity matrix whenever I need it. In this case, it's going to return a DirectX float 4x4, and that's the part that kind of binds it to DirectX. If we wanted to down the road maybe use Vulkan or OpenGL as our rendering engine, we would probably have to change this. Well, actually, we would have to change this to be something a little bit more platform agnostic. But like I said, since I'm really focusing on DirectX 12 with this engine, I'm not too worried about doing stuff like this. But just something to keep in mind anyway. Oh. Ah. Alright. Sorry, my keyboard's like just. I think it might be because I'm streaming it at the same time. It's been really weird today. Alright, so there we go. So So we don't need to take anything in, but we're going to return a identity matrix. And it's really simple to create an identity matrix. So if you don't know what an identity matrix is, it's a matrix with all of uh, the coordinates set to 0 except for each one in the x, y, z, and again, in this case you can call it w, whatever you want, the fourth column. Now it's a little bit different depending on what engine you're using. Either it's row major or column major. So it's a little bit different, and again, this would be something you'd have to think about if you were going to build this function out to work with both different like engines or different rendering APIs. But again, in our case, we don't have to worry about that, so we can do just our DirectX version. So float 4 by 4. And then we are going to just basically create this identity matrix. Very, very simple. So 1, 0, F, 0.0F. And you'll see the pattern that an identity matrix makes. And if you're kind of confused about any of the stuff that I'm doing, I did an MVA, Microsoft Virtual Academy, I shouldn't say a long time ago, a while ago, where we focused in on DirectX 11.2. And we walked through, building up some of the stuff and some of the steps that it takes to create objects, move objects around, stuff like that. So if you're looking for a deep dive on DirectX itself, that's a really good one to check out. Also, the book that I mentioned earlier check what I'm doing here. Frank D. Luna, absolutely fantastic. Definitely worth picking up. Alright, so there's our third row. And make our last one here. Alright, so yeah, so you notice the pattern that it makes is the ones going on a diagonal, and this, when you see this is the identity pattern. And I'm just trying to remember how it goes for the scaling. I got a cheat sheet over beside me here. No, I think it goes the same. Yeah, okay. I can't see it. Column order. Just looking to see if I can find the row order version. Yeah, it's the same. Okay. Anyway, I'll worry about that. Maybe I'll post that cheat sheet. It's actually a pretty cool little cheat sheet for working with 3D math. Very cool. Okay, so that's just going to return our simple identity matrix. So, oh, whoops, actually it won't return it because I didn't write the return. So, all we have to do here, return identity. Alright, simple enough. So now we have a very, very helpful function that'll return our identity matrix. So there's our, 4 different simple little functions that we built, but they'll go a long, long way in the future. Thinking about maybe doing the logging. Let's see how much time has passed on the actual recording. Let's see. I'm just going to look at my old logger and see how much I actually put into that. I'll go into streams a little bit, but nothing overly complicated. So, yeah, I've got a few minutes. Let's take a look at logging. Alright, so, for my logger, I'm not going to really do too much with it right off the bat. For the most part, I'm just going to use strings to save everything. What I want this class to do, so I wanted to basically hold a couple of different functions for writing to the log, but I was just thinking it through. I could basically use like a switch and have different type of logs, log types. That's how I've done it in the past. It's kind of a little weird. It's not an overly bad way of doing it. So yeah, we'll start out with the way that I've done it before in the past, and then we'll kind of go from there. So I'm wondering if I should do what I did in the past is I wrapped everything in a namespace, so that it was a little bit easier to find. So that, but in this case, I don't really. We'll worry about that later if we need to. So first we'll create an enum class called log type. And what I'm going to do with this enum is just basically use it to do like switches. So if the log for the data I'm passing through, if I want to save it to the error log, I can have an error log. So we can call one error. We can call another one runtime. You can have basically whatever you want here, is what, which is really, really nice. And then, I guess for simplicity's sake, all we really need to do right now is create one function. So I'm going to create a write log function, and it will take in our type. So that we can use that to switch, like I was saying. So we'll save it to depending on that. And then all the other thing we really need to do here for our log to start with is just take in a string. And we'll call this one log message. So nothing crazy in here for now, but we'll build this out as we go. Okay, so I'm going to implement it in here. Instead of creating like a CPP file and implementation file, I'm just going to do it all in the header. So the first thing we'll do is we're going to use the built-in stream system, so I should probably include stream. So we'll include file stream. Right one, yeah, okay. So we'll have a open file stream. We'll call this one error file. And what we're going to do is we're going to open up a file on our hard drive. Again, you probably wanted it to set this up so that you aren't just like hard coding in the name of it, so that it places it properly. But in this case, if I do it this way, it'll just put it in the runtime directory. So that's okay for now. And then we tell it. If you haven't done work with streams, you should definitely check it out. Very, very handy. So what we want to do here is we want to open it up in append mode. So that'll say basically if there's already an existing error log, it'll write to it. So the problem with like I'm writing this code as I'm going, I'm like second guessing how I'm doing it, but we'll just play it out and fix it up as we go. So then we'll have a runtime log. And we will call this one just saving them out simple txts, and again, do the same thing. So, and I'm not 100% sure I'm right on this, but the append will basically, it'll just add it to the file if it already exists, and if the file doesn't exist, it'll create the file, which is handy. It saves us having to do an actual check here to say, does the file exist? If the file does exist, add it, you know. Simple enough. And then what we could do is just do a simple switch case. I love IntelliSense, it's so awesome. Alright, so just adds everything for us. This time we'll switch on type. So depending on what type we pass in, we don't need a default. We'll say case log type error. So if it's an error, what we will do is we will write to our error file. So we'll use again our streams. And we will take our log message and we will pass it in as a C string. To do that, just use the C string function there. And we will also pass in an end line. And then we can close the file. So the file will be opened when this method's fired off. And yeah, both are being opened. Probably not the best way of doing it. So there is room for improvement here, but for simplicity's sake, it's okay. So we'll close it once it writes. That's just so that we're not having this stream just sitting open the whole time. So let's do another one for runtime. And just, yeah, I'm just going to do the famous copy and paste. Obviously it's still awesome errors, but in this case, code is not that different. So yeah, problem solved. Add a break. So now what's cool is, externally, what we could do is if we wanted to say something happened, or a player did something, or there was an error, all we have to do is say write log, and then just pass in the type. So we would say log type. If it was an error, say an error, and then we would pass in the error message. So it could be anything. It could be a string, like just saying problem happened, and that's all we would have to do. And then that would save it off into an error function. So if our program crashed and we wanted to find out what happened, what was the last error that popped up, or last thing that happened at the runtime, we could just go look back at our logs. So simple stuff there. Oh, what's it not like? Oh, yeah, just because I wrote the little class down there at the bottom. But yeah, or function at the bottom there just to show you what it would look like. But yeah, there you go. Simple enough. That's not an overly complicated logger, but as time goes on, we can add some functionality. But it does give us something, like I said, just to spit stuff out to, so we're not just printing to a console and hoping the console doesn't disappear, so we can collect data and stuff like that. And of course, I like to do things like for the runtime log, usually what I do is I'll print out the entire specs of the computer that it's running on, which is very, very helpful. You could also do the same thing in the error log at the very top of the error log. Some other things that we can do here too is we can save them, by date, things like that. So there's a lot of room for improvement here, and as I go forward, we'll definitely take a look at it. But I think I'm probably now over an hour in. So I'm going to kind of cap it here. We'll pick it up where we left off next time, and I'll write just the simple exception stuff, and then we'll kind of tie this all into the to the engine, and I'll start like doing some drawing and stuff like that. And we'll take a look at how I'm going to set those things up, and we'll try to do it in the best practices that we can. We'll take a look at different programming paradigms and methods that we can put into place as we're going, so that um, just so that you guys can see like the best things. Like I want to show you the best practices when you're building out an engine like this. So yeah, hopefully you enjoyed this and learned a little bit. Please feel free to drop any comments and stuff like that um, into the show listing there, or reach out to me on Twitter at ScruffyFern. I'm always happy to hear what you guys think, and if you have any suggestions or want to tell me how horrible my code looked today, always glad to hear it. But anyway, thank you very much for tuning in, and happy coding.